Good day everyone, we are Group 1 and today we will be reporting about Module 3 which is entitled Confined Space Entry and Fire Hazards. But before we get into today's lesson proper, let us first identify the intended learning outcomes. Number 1 is to list down some safety tips in preventing confined space accident, and number 2 is to differentiate fire detection, suppression, and fighting systems. Next, let's talk about confined space. So what is confined space?
According to Occupational Safety and Health Administration, or OSHA, a confined space is defined to have a limited or restricted means for entry or exit, and it is not designed for continuous occupancy.
So far, the primary examples of confined spaces are tanks, vessels, silos, storage bins, hoppers, vaults, pits, manholes, and many more. Let us define what is engulfment. It is primarily defined as the surrounding capture of a person by a liquid or a finely divided flowable solid substance that can be inhaled to cause death by filling or plugging into the respiratory system. Hazardous atmosphere is an atmosphere that may expose employees to the risk of death caused by one or more of the following. One is flammable gas, vapor, or mist. Two is airborne combustible dust at a concentration. And lastly is the dust obscures vision at a distance of 5 feet or less. So a confined space accident can be prevented if permit and procedures identified hazard are controlled. Through hazard evaluation via system safety analysis, identify specific areas of concerns, covering all aspects of the operation including personal error, environmental issues, design inadequacy, and procedural deficiencies. Countermeasures can be then used to complete a confined space entry permit, while the system safety analysis can be used to develop specific CSC procedures and for training and coordination through rescue operations.
No survivors, 3 fatalities. We're pulling the last one out now.
What happened? I can't believe they didn't follow the permits.
Scenes like this just shouldn't happen. And yet every year, across many types of industries, workers enter confined spaces much like this one and didn't get out alive. Our safe work practices and procedures, coupled with safety training and sound decision-making, are designed to prevent this type of needless tragedy. But despite the procedures and despite the training, scenes like this are still all too common. During this program, we'll explain what happened here and how these lives could have been saved. And in the process, we will explain why entering confined spaces can be so hazardous and how those hazards can be controlled by following proper confined space entry procedures. So, what is a confined space? The Occupational Safety and Health Administration, OSHA, defines a confined space as any area that isn't designated for continuous occupancy that is large enough for an employee to enter and perform work, and there is limited or restricted means for entry and exit. In addition to being hard to get into and out of, confined spaces can pose hazards to workers, such as fall hazards, physical hazards, or atmospheric hazards. Because of the dangers presented by confined spaces, OSHA created its Confined Space Safety Regulation 1910.146. This regulation contains requirements for practices and procedures which protect general industry workers from confined space hazards. This regulation requires that the workplace be evaluated for the existence of confined spaces and that those confined spaces be categorized into two types.
The following are the hazards present in a confined space. First is risk from noxious fumes, reduced oxygen levels, or a risk of fire. Second is flooding or drowning or asphyxiation from some other source, such as dust, grain, or another contaminant. What should employers do to prevent any confined space accident? First is, as much as possible, employer must avoid doing any task in a confined space. Assess the risk of the confined space and carefully plan in controlling those risks. Second is proper confined space training among employees. Third is employer must provide breathing apparatus or ventilate the space to increase oxygen levels before entering.
Now, let us know what are the do's and don'ts when entering a confined space. Here are the things that needs to remember for do's. First, it is important to be aware of the risk that may occur within a confined space. Second, always make sure the person doing the work is capable and trained in both, and the use of any emergency equipment to protect and keep safe from any risk that could possibly happen while inside of a confined area. On the other hand, the don'ts when entering the confined space are as follows. First, work in confined space unless it is essential to do so. Second, ignore the risk. Just because a confined space is safe one day, it doesn't mean that it will always be. And lastly, let others enter a confined space until you are sure it's safe to do so. The next topic that we will discuss is all about the fire and fire hazards. At the end of the lesson, the students shall be able to, first, explain why fire prevention is important to the processing industry, and second is to describe the 4 factors required for a fire to occur and keep burning. The key concepts under this topic are as follows. First is fire. It is defined as the chain reaction that requires a constant source of fuel, oxygen, and heat. Second is the fire hazards. It refers to a condition or material that may start or contribute to the spread of fire. It can be a ready fuel supply to increase the spread or intensity of the fire explosion and which possess a threat to life or property. Third is the combustion. It is the process by which fire converts fuel and oxygen into energy and usually in the form of heat. And lastly is the combustion point, where the temperature at which a given time or given fuel can burst into flame.
Fire and explosion accidents are a major concern to the owners and operators. According to statistics, in 2010, 77% of monetary loss in refinery and petrochemical complexes is caused by fire and explosion. Also, 65% of accident breakout is due to fire and explosion, and 35% is caused by vapor cloud explosion accident. The cause of these accidents are mostly attributed to mechanical issues, operator error, and process upset. These are the factors that can prevent a fire: sprinkler system, infrared detectors and alarms, portable fire extinguishers, fire monitors, fire pumps and fire water, firefighter training, fire brigade, fire trucks, and mutual aid agreements. Fire prevention and firefighting are critical issues with processing industries. There are 3 fire hazard substances that can start and sustain fire. These are oxygen, fuel, and source of ignition.
The figure presented on the slide shows the different classification of fire. This classification system helps in the assessment of hazards and quickly identifies which is the most effective type of extinguishing agent to be used. We have a total of 4 classifications, which are the ordinary combustible, flammable liquid, electrical equipment, and combustible metal. The Class A consists of wood, paper, cloth, rubber, and plastics. On the other hand, Class B, which is the flammable liquids, are the gasoline, oils, alcohol, etc. The Class C is also known as electrical equipment, which is more on computers, appliances, or anything that is powered by electricity. And lastly, the combustible metal, which are the magnesium, titanium, etc. Moving forward, we discuss also the fire hazard. We have the flash point and fire point. On flash point, it is the lowest temperature at which a liquid can give off vapor to form an ignitable mixture in air near the surface of the liquid. The lower the flash point, the easier it is to ignite the material. A closely related and less common term is fire point, the temperature at which the flame becomes self-sustained so as to continue burning the liquid. At the flash point, the flame
does not need to be sustained. The fire point is usually a few degrees above the flash point. As we all know, firefighters are responsible for putting out a fire. Furthermore, it also helps with hazardous materials, road traffic incidents, medical emergencies, and floods.
Numerous plants employ a variety of techniques to find, put out, and/or combat flames. Several of the devices, in addition to locally alarming at the site of the fire, can also remotely warn the emergency management office or guardhouse at the same area. All of the systems will be covered. The majority of industries employ automatic fire detection systems today. They send alerts when smoke, radiation, high temperatures, or increased light intensity are present. Several of the types of detectors include thermal expansion detectors that make contact and emit an alarm when a heat-sensitive metal link melts at a specific temperature. Photoelectric sensors that detect changes in the infrared energy emitted by smoke or by smoke particles that block the photoelectric beam. When smoke reduces the photoelectric beam's intensity, a relay closes to complete the alarm circuit. Sensors for ionization or radiation that rely on a radioactive substance's tendency to ionize when exposed to smoke. When exposed to smoke, the material turns electrically conductive, enabling the completion of the alarm circuit. Ultraviolet or infrared sensors that sound an alarm when the radiation from flames are detected. There are several techniques of fighting and reducing fires. We will examine 5 different ways to put out fires: isolation, water, gas extinguishers, foams, and solid extinguishants. Isolation. It is possible to separate the fuel and oxidizer in a number of methods. An upstream valve can be closed if a fuel burst pipe is feeding the flames. As a result, the fuel source is isolated. Isolating the fuels from the air requires covering it with foam or inert gas. Water. The most popular fire extinguishant is water, since it is widely accessible, inexpensive, and efficient. It is frequently applied to Class A combustibles. With the benefit of being far from the fire, firefighters can apply the water in a stream. Water can serve as a coolant by being sprayed or vaporized, by absorbing the heat of vaporization and stopping chain reactions as spray or fog cools. Gas extinguisher. Although they are less frequently used than water, gas extinguishers can sometimes be more effective and are the preferred approach when a fire is in an enclosed location. The equipment inside of the room is of high value. The types of gas extinguishers are carbon dioxide, the most common gas extinguishant; nitrogen acts as a diluent and reduces concentration of oxygen; and halogenated hydrocarbons acts by inhibiting chain reactions. Foam. By cooling, covering, and isolating the burning fuel from the surrounding atmosphere, foams put out fires. As a result of heat or water, foam eventually degrades. Solid extinguishants. Solid extinguishants are mostly utilized to put out Class B fires, such as grease or oil fires. A solid extinguishant has the advantage of staying put on a burning surface without blowing off. The main solid extinguishant used on liquid fuels are sodium and potassium bicarbonate. Firefighting tools may be manual or mechanical, portable, mobile, or fixed. Due to the importance of having functional fire extinguishing equipment, site equipment inspection schedules are followed and documented. Equipment that is broken is immediately replaced. Firefighting equipment that would be on their checklist include fire extinguishers, handheld and mobile, fire monitors and turret nozzles, grade and elevated, fire hose stations, fire hose carts, and SCBA stations. Additional firefighting equipment and processing industries include sprinkler systems, halon systems, handheld portable extinguishers, and mobile fire sprinkler and halon suppression systems are typically ceiling-mounted permanent systems. The first discharges a flood of water, while the second discharges a gas that suppresses. Because halon gases are harmful to the ozone layer, halon systems which employ the gas by that name are being phased out. Handheld fire extinguishers can be loaded with foam, carbon dioxide, dry powder, or water. Depending on the size of the extinguisher, the chemical within, they can be used from 8 seconds up until 120 seconds. Mobile fire extinguishers are often mounted on a cart with two wheels. They resemble handheld fire extinguishers but are much bigger and heavier, making them impossible for men to lift.
Before we end our presentation, I would like to introduce to you the members of Group 1. We have Ms. Nyami Kobugon, Ms. Crisel Dagami, Mr. Luz Mindagarbo, Mr. Marv Hernandez, Ms. Shanat Himino, Mr. Ian Inay, and Ms. Juna Lazaro. And that concludes our presentation for this evening. Thank you for listening and have a great day ahead.